Now, regarding the solving, I did already solve them all, and I've also handpicked a couple of questions that I'll be going over, because not all questions need me to go over, such as anything that has an M beside it. M is for memorization and S is for solving. And solving, by solving I mean equations to be specific. Okay, let's start with 8. I'm going to be using this sheet of paper as like a white scratch paper. Now what does 8 say? 8 wants specifically the centripetal force. So if we could recall really quickly what the centripetal force was, it was F equal M and A. We could of course transform that A into V power 2 over R, which I think is what we're going to need here. The body is rotating in a circular path by tangential velocity of 10 meters per second, where the mass of the body is 4 kilograms and the radius of the circular path is 800 centimeters. As I've talked in the previous video, there is an international system of units. The 800 centimeters needs to be converted to meters. And we said we're gonna do that by 800, of course, divided by 100, which is going to be 8. So let me just plug in the numbers, which is going to be 4. Wait, can you even see the calculator? Oh yeah, you can. Amazing. It's 4 times V power 2, which is 10 power 2 over 8. And it gives you 50. There you go. That's the first one. Now, second one, it wants centripetal acceleration, number 9. The acceleration was equal to V power 2 over R radius. Amazing. If a ball is rotating in a circular path by a velocity of 2 meters per second, and the radius of the circular path is 0.1 meters, so centripetal acceleration equals to, let's calculate it. Amazing. This one is straightforward. 2 power 2, which is 4 of course, over 0.1. The answer is going to be 40. There you go. 11. Also, I do have another sheet that's full of these equations done step by step. I could also show it to you guys after we finish solving. Okay. Now what does it want first? I always try to extract what it wants first so I'll know what I'm searching for. It wants the centripetal force. So it's instantly going to be F equal mass times acceleration. And let's first see what the equation gives us. For a car moving in a circular path of radius 20 centimeters, where it made one cycle through the time of 5 seconds, and the car mass is 300 grams, the centripetal force equals... Okay, we first have to transform two things. Also, I think we're going to be using a different equation for this one. This one is going to be 4 pi power 2, and then what was it? Mass times radius over periodic time to the second power. That's the equation we're going to be using, since this is what it gave us. Of course, if you just want to use whatever the equation gave you to make it into like velocity or acceleration, you're free to do that. This is just the faster way of getting through it. Now, let's start converting. We have the radius, which is 20 centimeters. It's going to be 0.2. So let me just write that down. Radius 0.2. Or actually scratch that. I'm just going to do 4 pi power 2. And then what's the mass? The mass was 300 grams. It has to be divided by 1000. So it's going to be 0.3 times 0.2. Of course, you want to place a multiplication sign between them all. Over. It's going to be over t power 2, and our t was, it made one whole lap through 5 seconds. So it's going to be 5 power 2 or just 25. Calculate it. Three times 0.2 over 5 power 2. And okay, what is that answer? Oh, amazing. Don't forget the powers. There we go. Yeah, that's the correct answer. I was scared for a second. Okay, I'm also going to go through converting this really quickly, since I did say you can just convert it. Okay, now we have t which is 5, and we have the radius. Yeah, amazing. So we can actually just get the velocity, which was 2 pi r over t, right? I think so. I hope so. Yeah, it is. Amazing. I got scared for a second again. So we're going to do 2 pi 0.2 over 5. Pi 0.2 over 5. It gives us this number, 2 over 25 pi. And now we're just going to, what was the mass? The mass was 0.3. 0.3 times, we have first, I'm just going to put in the answer. I really don't know what it was. I think it was 5, no, it was 2 over 25 pi. It would take too much time writing that, so I just put answer, power 2, and it was, wait, yeah. Yeah, there we go. Yeah, I'm just spacing out every 2 seconds, sorry. So the answer is going to be 0.094. Now, number 13, we'll just write that down. If the centripetal acceleration, oh wait, what's the question first? It wants tangential velocity. If centripetal acceleration of the body is 5 meters per second squared, and the orbital radius is 5 meters, then the tangential velocity equals, let's go through it. It gives us acceleration, and we know acceleration is equal to velocity power 2 over r. So we could say the 5 is equal to x power 2 over the radius, which was 5. I don't think this needs much of a calculator. It's going to be 5, but for the sake of safety and just completeness, I'll do it. X power 2 and 5, shift solve. Yeah, it's 5. Go. So the amount of questions I'm going to be doing is 24, by the way, I believe. 24 or 14, I genuinely cannot remember for the life of me. A ball attached to a rope is moving with a constant speed on a horizontal circular path of radius 0.6 m. If the ball completes 2 revolutions in 1 second, the centripetal acceleration equals, okay, it wants the acceleration, which is equal to v power 2 over r. This question is a heavy load of things. It gives us the radius, which is equal to 0.6 meters to be specific, and it gives us the frequency. It gives us the frequency, which was just 2. Does it give us anything else? It does not give us anything else. Okay, now we can actually get the frequency was the amount of cycles done we just write that frequency is equal the amount of cycles done over whatever time. So all we need to do to get the periodic time, we'd need to switch these two, which would mean it's going to be 1 over 2 or just 0.5. I like to work with decimals. So how are we going to use this? We're going to use this to get the velocity, which was v is equal to 2 pi r over periodic time, which is this. So now we can do, let me just use the calculator instead. Place it down, no? Yeah, maybe. I think y'all can see good enough, maybe. Six, and then over periodic time, which is 0.5, and that is our velocity. So we're going to do this. We're going to put the answer, the velocity power 2 over 0.6, and the answer is 94.75 if you round it up, of course. Now 15. Getting out of hand. What does it want? It wants centripetal force. We just write down the force equation. Force is equal to mass times acceleration. A stone of mass 600 grams. Let me make a list. The mass is equal to 600 grams or just 6k. Or wait, no. It's 0.6 kilograms. That is tied to a string length of 50 centimeters. So we know that's 50. So we know the radius is 50. It needs to get divided by 100. The radius is equal to 0.5. Yeah, it says 0.5. 0.5 meters at a speed of 3 meters per second, and the velocity is equal to 3 in a horizontal circular path, hence the magnitude. Okay, we don't need to get anything out of this, we just need to plug them in, which is going to be, we're going to be using mass times v power 2 over r. Let's do that really quickly. 0.6 times v power 2, or v was 3 power 2 over 0.5, which is 10.8. There we go. If the wait, what does it want? Oh, I think this is the first question that's going to be regarding the force. Okay, I don't think we're going to need much calculator. This is going to be abstract work. It tells us if the attraction force between two masses mx, and then which is 1m, and my 2m was F, then a mass m has been added to each of the two masses. The attraction force between them becomes, okay, so first we need to get the first F, and I think the gravitational constant is just going to be the same throughout them, so it's going to be m, and then 2m over the radius r. There's supposed to be a g over here, sorry, and then that's the first one. Now the second one is F equal g, and it said there has been a mass added onto each, so this is going to be 2, this is going to be 3. Okay, what am I doing? 3m over r. We're going to assume that the radius and the gravitational force are the same, so the first one is just going to be 2m. Let's call this f1, let's call this f2. f1 is equal to 2m, and f2 is equal to 6m. Now he wants the ratio. Dash actual force, but no, he does not want the ratio. Well, anyway, we're going to divide f2 over f1 to find the difference, which is going to be 3f. And there is your answer. 17. Two balls have the same mass, have the two same masses actually. If the distance between their centers is 2m and the attraction force between them is 6.6 times 10 to the negative 9, then the mass of each ball equals... Okay, for this we're going to... I personally will solve it by doing the gravitational constant. G is going to be equal to 6, 7... Oh wait, why am I just writing it out? It's going to be fr power 2. The two masses which are the same, so we could say that it's mass power 2. Now we've already learned the gravitational constant, so we could just do it by gravitational constant is equal to 6.67 times 10 to the power of negative 11. Oh wait, y'all couldn't see that part. It's going to be 6 over 2. That's why it's 3f, by the way. That's the gravitational constant, equal to 6.67 times 10 to the negative 9 power, and the radius was 17, question 17. The radius is 2 meters, so we could just say 2 to the second power over the two masses, which is just going to be x power 2. There's also another way to solve this. I would be going through, or I'm going to be testing another way to put it in other words. Times 10 equal 6.67 times 10. Whoa, that is not 10. 10 to the power of negative 9, and then which is times 2 to the power of 2 over x to the second power. Shift solve. Let's wait. $20. There we go. Now that's the way that you solve it through the gravitational. I just want to test if we could also solve this by doing the force. Does it even give us a force? It does. So let's say the force was 6. The force is already 6.67 times 10 to the power of, what does it say the force was? Negative 9. Oh, let me also write it down for you guys. Force is equal to G, and then mass, and then R power 2, right? Yep. Two are directly proportional, inversely indirect again. Okay, so we know already the gravitational is equal to 6.67 times 10, and then negative 11. And then now we put, well, okay, that is not what I meant. Okay. And then we start working with what we have, which is the x's are power 2. Now, also, by the way, why am I putting the x power 2? We're putting the x's power 2 because it states that they already have the same mass. If it wasn't for that, the x wouldn't be power 2, it would be two different numbers, I believe. So you just want to look out for that. And then you have over radius, which is 2 power 2. Shift solve again. Oh, it's just 20 again. So you could solve it both ways. So that's 17. 18. Oh no, 18 is memorization. 19. What does it want? It wants... Okay. This is going to be an abstract question, I believe. If the distance between the centers of two bodies is doubled, the mutual attraction force between them will be... Okay. Let me just write that down. G, M, M. By the way, this is the first mass, the second mass, or you could do them whatever way you want. And the radius power 2. We said both of the masses and the G are both proportional, where actually the radius is inversely... Wait, let me just put direct... Or actually I don't have enough space. Inversely proportional. Now what do we do with this information? It said the distance doubled. So if the distance were to be doubled, this r would be 2. And since the radius is powered by 2, it's actually going to be 4 times. So it's going to get quartered. That's 19. 20. If the distance between the centers of two bodies is doubled again, only one mass of the two masses increases to double, then the mutual attraction force between them will be... Let's go over it again. We already said that the masses are both directly proportional and the radius is doubled again. So if the radius became 4 and the masses, they're both not, it's only one of them is multiplied by 2, so it's just going to be 4 over 2, which is just 1 over 2, which is half. So your answer is, of course, going to get halved. As you can see, these abstract questions are just all about knowing what is directly proportional, what is inversely proportional, and being able to write them down. As in, if this was just 1 and it told you it got doubled, you'd put this as 2 and then you'd do, or like you'd continue with its factors. Never forget the factors, by the way. What's next? 21. If the distance between the centers of two bodies is doubled again, and both of the two masses increases to double, then the mutual... Okay. We said that both of the masses are directly proportional and the radius is inversely proportional. The radius is still doubled, so this is going to be 4, and this time both of the masses are doubled, so this is like saying that its mass, it's 2 to the power of 2, so it's going to be 4 and thus is going to remain constant. I think this is the last question you guys could see on the camera. No. Okay. The moon has a mass of 7.4 times 10 to the 22nd power kilograms. Okay, that's a big mass. And a radius of 1.7 x to the power of whatever at this point. What is the gravitational force experienced by a bibin or a bibin, a 70 kilogram astronaut standing on the lunar surface? We're going to actually be using F is equal to G and then mass 1, mass 2 over the radius to the 2nd power. So does it give us the force or does it give us the gravitational? Oh no, we want the gravitational, so I'm guessing we have the force. I mean, we already do have gravity. Negative. The mass, which is 7, let me just put it between brackets, it's like one whole mass. 7.4, 10 to the power of what? 22. Oh, that's going to be a large number. 22, and what is it? Okay, times 70 over the radius, which was, let me also put it between brackets, 1.7. Okay, also, I'm putting them between brackets so the power 2 applies to both of them, especially in the radius where it's going to get powered by 2. 1.7 times 10 to the 6th power, and then power 2. Yep, there you go. The answer is 120 if you round it up. Now 23. I'll actually write them down, but I have them written down on another paper. Yeah, I'm just going to note 23 is out. It's going to be 23 is memorization. 24. A body rotates in a circular horizontal path which makes a half cycle in 3 seconds. If the body displacement through the half cycle is 2 meters, this is, I think, okay, I think this is diameter, I believe. Yeah, say so. Cycle is 2 meters in such per, okay. Acceleration is equal to v power 2 over r. That does not look like an r. Okay, and it gives us, let's also list what it gives us. It gives us half cycle in 3 seconds. Okay, we want a full cycle for periodic time, so we're just going to multiply it by 2. So it's just going to be, the periodic time is going to be 6. And displacement through half cycle is 2 meters. V is equal T. There we go. And the half cycle is actually the full diameter, so the radius is going to be 0.5, I believe. Oh no, it's just going to be 0.1. I just divided 1 by no. Uh, 2 pi r, which is 1, and then wait, oh, I forgot your multiplication signs, I guess. Then this, you put this over here, answer power 2 over 0.1. No, why am I putting 0.1? It's just 1. Yeah, it's going to be 1.096, which you're going to round up. It's going to be 1.1. Next question. Wait, am I doing this? Yeah. Okay. 25. What does it want? Hence the centripetal. Okay, it wants centripetal force. The force was already equal to mass times acceleration. Now what does it give us? We get the mass. A body of mass 0.5 kilograms is moving in a circular path of radius equal to 2 meters. And we have the velocity, which is 10. Amazing. We're going to be using v power 2 over r, 0.5 times v power 2, which is 10 power 2 over 2, which is equal to 25. To 27. A body, okay, wait, what does it want? It wants force again, mass times acceleration. What does it give us? A body of mass 4 kilograms, okay, wait a minute, a circular path by tangential velocity of 2 where the radius of the path is 1. Calculate centimeter 4, okay. V power 2 over R. 4 times V power 2 power 2 over 1. 16. A body of mass, okay, what does it want? It wants centripetal force again. Force equal mass times acceleration. Let me just put this part. A body mass of 2 kilograms moves in a circular path with a radius 0.3, where it completes 1 cycle in 5 seconds. We have periodic time. And actually for this we're going to use 4 pi to the power of 2 times mass, which is, and 0.3 over 5 to the second power. And there's your answer. Okay, question 29. A bike moving on a circular road by velocity, okay, what does it want first? It wants acceleration. Acceleration is equal to velocity power 2 over radius. A bike moving on a circular road by a velocity of 20, so velocity is equal to 20, where the radius is equal to 100 centimeters, so we're going to divide that. The radius is 1. You divide centimeters by 100 to get the meters, by the way. I talked about it in the previous video, where it's international system of units. Then calculate the centripetal force, centripetal acceleration. Okay, so this does not need a calculator either. It's going to be 400, I believe, but let me just go through it. 20 power 2 over 1, 400. There we go. Next question, 31. What does it want? Oh, this is just going to be hypothetical situations. State what happens to a centripetal force when the masses of the body increases to double. So the mass increased to double. Let me just put it. The equation is V power 2 over R. We already know that mass is directly proportional, so it's going to be 2m. Increase to double, and also the velocity doubles. So the velocity is going to be 2 power 2, which is 4. So, and since these already get multiplied together, the mass and velocity gets multiplied together, it's going to be 8 over 1. Since the radius stays as 1. And what does it want? Oh, it increases 8 times. Question 32. Put a force with equal masses, which is m, v power 2 over r. Okay. Acting on two bodies of equal mass, the first body moves with the speed of 5. Yeah, it's 5 power 2. The horizontal diameter of 4m, which is going to be 2. There is no way. Wait, what? Oh, what? Oh, yeah. I think I got the problem now, and I'm so sorry. Edit, so it's 10 over 2. I treated the power as a multiplication. Okay, that's why sleep is important. Then 10 over 4 is equal to 25. It's not 20 either. Oh my god, sleep is so important. So the ratio is 1 over 2. I was correct at the beginning. Holy, I'm so sorry for that. Wait, can you guys even see it? Yeah, I think so. Yeah. Holy. Now, what about... Okay. Actually, new profound insight. About question 33, I just do some digging. Okay, we have F1, which is the first one, which is just normal. Mass time is v power 2 over r. We have F2, which is mass v power 2, but this time the radius gets quadrupled. Now what do you say about the radius? The radius is inversely proportional. So this is going to instantly be 1 over 4. Since this got time multiplied by 4, this gets divided by 4, right? Now it's asking what would we need to do to the first speed, or like the first one, for it to be the same as the second one. We're just going to need to decrease it to a quarter. That's how you solve it. Back on the same page, I guess. What is next? 40. Oh, this is not actually solving. I just wanted to tell you about this thing. If a ball rotating by a mean of tension force 8n and the centripetal force increased to 10n, then what will happen to the rope? The rope already states that the tension force, or the mean of the tension force, is 8n. Now what does that mean? That means that the rope can only hold up to 8n before it happens, or like it gets ripped apart, basically. So the answer is going to be will cut and the ball will leave in the direction of motion, since it's still going to be moving in velocity, and as we said, it is just going to be tangential to acceleration, so it would go in that direction if it were to ask so. Now 42. Okay, amazing. Illustrate what would happen. Centripetal force of velocity increased 5 times. Centripetal force, which is mass time is a, or just mass v2 over. Yeah, there we go. If the velocity increased 5 times, so it's going to be 5 power 2, which is 25. The mass is still the same, I believe. And the radius increased 25 times. It's just going to be 1. It remains constant. If two bodies of x and 8x respectively, then the force of attraction that y affects x to the force of x affects y. Remember how I said basically there is a law that says every action has opposite reaction. When I am pulling on this pen as much, or like when the earth is pulling on me, I am also pulling on it back, so we both have, or like we're both sharing the same attraction, so it's going to be 1 to 1, since we're both doing the same force, since we're both attracting each other by the same force. Let me also get out the other sheet that I was telling you guys about. I've already solved everything with steps, I believe. Here it is. You guys could take a screenshot. This is of course how I solve it. Very important, number 22, you want to have the brackets, as I've said.